Hey guys, welcome back. In today's video, I'm actually going to be answering that mystery question that I talked about last week and the week before when we reviewed special right triangles right after we did SOHCAHTOA. So today's the day where you're finally going to figure out how does all this unit circle stuff connect to SOHCAHTOA? Why did we do a random SOHCAHTOA and special right triangle review in the middle of all this? So let's answer that question. First, let me remind you what are the two types of special right triangles that we had. Well, we had a 30, 60, 90 triangle that looks something like this. The 30-degree angle is across from the shortest side, and the 60-degree angle is across from the longer leg. And remember that the rules for that is whatever the short leg is, I'll make that A. The hypotenuse is going to be double that, and the longer leg is going to be the square root of 3 times the short leg. That's our rules for that. Okay, so I want to look at a 30, 60, 90 triangle if I were to draw it like this, just taking it and rotating it sideways. And we'll make the 30-degree angle, well, it has to be right here because it's across from this short leg, which means the 60-degree angle would be right up here, and that makes sense because it's across from the long leg. Okay, so we have the exact same thing, a 30, 60, 90 triangle. And what if we say the hypotenuse on this is 1, and I tell you to solve for this triangle? So what would be the other things? Well, remember that the hypotenuse is always double. It's 2 times whatever the short leg is. So if the hypotenuse is 1, and that's double something, what is it double? Well, it's double 1/2. So I know the short leg would be 1/2. So then, if I know, and I'm going to change colors to black now, if I know that the long leg is square root of 3 times the short leg, then down here I'm just going to take the short leg and times it by the square root of 3. Now, of course, I can simplify that. Instead of saying 1/2 times square root 3, I could just write it as square root 3 divided by 2. And there's no square root in the denominator, so I don't need to rationalize. I don't need to go any further. Okay, so this is the picture that I need you to remember for the next slide, this picture right here. And before I flip to the next slide, let's do the exact same thing with a 45, 45, 90 triangle. So if you think about a 45, 45, 90 triangle, so both of these angles are 45 degrees, remember that makes both of the legs the exact same length, and the hypotenuse is square root 2 times the leg. So if we do the same thing, if I imagine a 45, 45, 90 triangle, just drawn sideways this time, and I tell you that the hypotenuse is 1, then let's figure out what the legs would be. Well, remember the hypotenuse is square root 2 times the legs. And if the hypotenuse is equal to 1, then I just write equal to 1 and solve that equation. Let me clean that up a bit. So how do I solve this for A? I would divide by square root 2. So I have A equals 1 over square root 2. And that's almost good, but I would want to rationalize the denominator. You always want to do that. Never leave a square root in the denominator. So I'll multiply top and bottom by square root 2. And I get square root 2 over, and the bottom, this part, would just be 2. So that means that both of the legs would have been square root 2 over 2. And we've solved this triangle. Okay, so this picture is one that I want you to remember as well as we move on to the next slide. In fact, I will just erase this stuff because this was just showing us what the rules were, and then we used it on this specific example where the hypotenuse is 1, the ones that I have boxed in red. All right, so how does that relate to the unit circle? That was the big mystery question that I kind of kept hanging for a week or two. And the whole reason why we reviewed special right triangles is for this slide right here. This slide is the most important slide of, honestly, the whole week. So this is a really important one to listen to. It's going to be a little bit longer, but this really is everything I'm going to teach you. And then after this slide, we're just going to do examples. So remember, the unit circle is called the unit circle because it has a radius of 1. So if I draw this line, I know that has a length of 1, this one has a length of 1, this has a length of 1, right? Any of these radiuses all the way around have a length of 1. Okay, so now let's look at this angle right here. Remember that line formed a 45-degree angle. Okay, so if I turn this into a triangle, and I say, like, hey, I'm just trying to figure out what are these coordinates right here. Like, if I were to list the XY coordinates, what are they? Right here at this dot. Keeping in mind that this dot down here is 0, 0. And remember, we know everything has a radius of 1. So if I follow this line straight out to here, then this would be 1, 0. So I know that coordinate, and likewise, I would know all these coordinates. This would be 0, 1, because it goes out nothing, but it goes up 1. This one over here would be -1, 0, and this one would be 0, -1. So this just shows me how I can go out or up each time with a unit length of 1. But what would be like some of these ones on the circle? Like, what is the xy coordinates of this point? So that's what these special right triangles are going to help us with, because we know, since this is a 45-degree angle, I can think about picking up the 45-45 triangle that I put right here, pick that up, because this was a 45-degree angle, and place it right here. And the reason that works is because in this example, my hypotenuse was 1. And over here, this radius is a length of 1. So I already know the side lengths of this triangle. If the hypotenuse is 1, I've already solved for the other legs. It was this number, square root 2 over 2. So let's fill that in. And remember also how xy coordinates work. If I'm trying to figure out this piece right here, what are the coordinates right here? This first one is our x coordinate. That just means how far is it going over. So from the origin, from right here, how far did I go over to get to this point? Well, I went over this much. What was the length there? It was square root 2 over 2. And then this coordinate, the second one, the y coordinate, is measuring how much I went up. So from here, from the origin, how far did I go up? Well, that can be measured by this distance right here, which was also square root 2 over 2. So by picking up this triangle right here, the 45, 45, 90 with a hypotenuse of 1, and placing it down in the unit circle, that gives me these coordinates. The reason that's helpful is because now when I ask you to evaluate certain trig functions, you can use these coordinates to help you, and you won't have to calculate anything in your head or solve another triangle out. You will just know the answer automatically. Okay, so what if I asked you to do something like, tell me what the cosine of 45 is? Just straight up, what's that value? Without typing it on your calculator, because I want to get an exact answer. Well, we have a triangle right here with a 45-degree angle. So based on this 45-degree angle, the cosine, which remember is adjacent over hypotenuse, that would be, based on this triangle, the adjacent side is right here, square root 2 over 2, and the hypotenuse is just 1. Well, over 1 doesn't really matter, so that part you can basically just take off, which tells me that the cosine is this right here. It ends up always being the x value of these coordinates that we found. Let me do another example, because you might be wondering, why is it not the y value since they're the same? And we'll see that better once we do a different angle besides 45. Okay, so what if I asked you something like, what's the sine of 45? Well, based on this triangle and SOHCAHTOA, remember that sine is opposite over hypotenuse. So from this angle, the opposite side is square root 2 over 2. And the hypotenuse is 1, so I don't need to write over 1. Which tells me that the sine value is this one right here. It's always going to be your y coordinate. Okay, so things you need to get from this slide, and we're still not quite done, but here's the things you need to know before I erase the screen and move on. You need to know that I got these x and y values here and here by picking up this triangle, this 45, 45, 90 triangle, and placing it on my unit circle. Okay, the second thing you need to know is if I ask you the cosine of an angle, you always look at the x value, and if I ask you for the sine of an angle, you look at the y value. So let me do this again, except for with a 30-degree triangle. So we know that the 30 degrees happens right here. So imagine that I just put a triangle down, and I'm doing my 30, 60, 90 triangle right here. So just imagine picking up that triangle and placing it right here. Well, the hypotenuse is 1 because this is a unit circle where all the radius is 1. And that matches the picture here because I did have the hypotenuse as 1. So now just fill in the other sides. I need to write 1/2 and I need to write square root 3 over 2. So this part's 1/2 and this part was square root 3 over 2. So now if I ask you for these coordinates right here, well, I would know that the first one is just, remember, it's the x value, which is how far over it goes, which in this case, the length of that horizontal distance was square root 3 over 2. And the y value is how far up something goes. So at this point, how far up is it? Well, it's 1/2, measured by this length right here. So now if I ask you something, and I'm going to write in that this was a 30-degree triangle. So now if I ask you something like, what's the sine of 30 degrees? Well, you know based on our SOHCAHTOA work that sine is opposite over hypotenuse. So from this triangle, the opposite side is 1/2, and the hypotenuse is 1, which I don't need to write over 1. So the sine of 30 would just be 1/2, and notice that's the y coordinate. So as we move forward, if I ask you for sine of 30, you really don't need to do opposite over hypotenuse anymore. You can just look at the y value of the coordinates because that will always be true. Let's do it now, but I'm going to ask you for the cosine of 30. So cosine of 30, remember cosine is adjacent over hypotenuse. So from this angle right here, the adjacent side is square root 3 over 2, and the hypotenuse is 1, which doesn't really matter if we write that in. So that tells me that the cosine, square root 3 over 2, is this value right here, which ended up always being the x value. So again, this proves that if I ask you for the cosine of an angle, just look at the x value on the unit circle. And if I ask you for the sine of an angle, just look at the y value. And then you can skip doing the opposite over adjacent stuff, and you don't really ever have to solve for that again. Okay, so the last one that we haven't really done is this one right here for the 60 degree. So let me clear the screen and imagine that we drew in another 30-60 triangle, but this time it's just rotated. So I can still fill in the values by copying this triangle right here. I just have to rotate the picture. So remember the short side is 1/2. So this side right here is 1/2, and the long side is square root 3 over 2. So this one's square root 3 over 2. Still, this diagonal, the hypotenuse, is just a radius of the circle, so it's still 1. So it still matches my picture exactly from the previous slide. So now if I ask you for the coordinates of this spot right here, remember this is still 0, 0. Well, my x value, the first coordinate that I fill in, is just going to be the horizontal distance. How far over is this red dot? Well, it's over by exactly the distance of that triangle, which is 1/2. And it's up by exactly the distance of that triangle, which is square root 3 over 2. So now if I ask you for something like the cosine of 60, and I won't actually solve for this using SOHCAHTOA, I'll just do the pattern that I keep telling you. That's just always going to be the x value of that coordinate, so it's going to be 1/2. And if I ask you for the sine of 60, that's just going to be the y value of the coordinate, which is square root 3 over 2. So I can start doing these problems a lot faster without doing SOHCAHTOA. So basically, if you know the coordinates all the way around the unit circle, you won't have to do SOHCAHTOA for any of those degree values. Now, the other big question, this is the other really big part of today's lesson, is I just taught you what the coordinates were for only this dot, and this dot. But what about all these other ones around the unit circle? Do I have to memorize those as well? Well, the answer is once you actually know the first quadrant, and when I say quadrant, I mean just this first section, this whole part of the unit circle. This is quadrant 1. Once you know that, you actually know all the rest. So that's why I'm only focusing on the first quadrant. And let me show you what I mean. So I'm going to clear the screen, and I'm just going to fill in the coordinates that we learned so far. So here's the coordinates that we learned so far. These are going to be 3 that you really want to memorize because you don't want to have to think about resolving out these triangles and then picking them up and putting them in the circle. That just kind of explains why it works, but eventually you want to get to the point where you can just write these down without having to resolve it. So some ways that I always remembered in high school is if you start from up here and you go down, notice that the numerator, and by the way, I'm saying numerator because look at the denominator in all of these. All of them are over 2. So that part's easy. You don't really have to remember that. The only hard part is what is the numerator? So if you look here, up here and going down, it goes 1, 2, 3, and then it circles back up 1, 2, 3. So that's how I always remembered it, was going down 1, 2, 3, and then you go up 1, 2, 3. The other thing you can remember is the one always in the middle is the one with the 2's. Square root 2 over 2. That's always going to be the ones in the middle. And the one on the top is just a flipped version of the one on the bottom. And that just comes from the 30, 60, 90 triangle just rotating. So that's why those coordinates just flip-flop. The other thing I want to point out is that technically there is a square root on everything in the numerator. So that's another thing that sometimes I think kids have a hard time like remembering is like which ones have square roots and which ones don't. Because if you see, this is square root 2 over 2, this is square root 2 over 2, this is square root 3 over 2, but then ones like this is just regular 1/2. Well, technically you can think about it as square root 1 over 2, but what is the square root of 1? That's just 1. So if it helps you to think about all of the numerators have a square root, and then we just took it off for 1, since square root of 1 is 1, then sometimes that helps as well. Okay, so here's those coordinates again. Find some way that helps you memorize the order of these and that you know which angle these go with. So this one up here goes with 60, this one goes with 45, and this one goes with 30. In fact, I will actually color code those coordinates. And think back to last week when I had you draw rectangles for the ones that correlate to each other. So let's just look at the green ones. When you drew in a rectangle, it matched with these ones. These were all the ones that had a denominator over 6. So when we did it in radians, this one was like pi over 6, and then way over here ended up being 5 pi over 6. And this was 7 pi over 6. And then this last one over here was 11 pi over 6. So all the ones over 6 were closest to the x-axis. And the cool thing is all of these ones, and I'll draw my little rectangle again, they're all going to have the exact same coordinates as this one. So once you've memorized one of them, you have the rest of the ones that correlate to it all across the unit circle. So I can fill in the coordinates for all of these as the same as in the first quadrant, square root 3 over 2, comma 1/2. The only thing that will have to change is the sign. And what I mean by that is some of them are going to have negatives. And the way you figure that out is super easy. If you start at the origin and you're going backwards, that means that x is going to be negative. But for the y, we still went up, so your y coordinate is still going to be positive. So for this one over here, you just have to put a negative sign for the x coordinate since we went backwards. Okay, let's do this one right here. So this one, I went backwards to get the x, so that's going to be negative. I also went down for the y, so my y coordinate is also going to be negative. And now let's do this one over here. My x coordinate, I went to the right, so I went in a positive direction, so this is going to stay positive, but I went down for the y coordinate, so that's going to be negative. So adjusting for the correct negative signs, look at all the green ones I have filled in. The awesome thing is I really only had to memorize it one time over here for the first one, and then just knowing that these all correlated to each other, and the mathematical reason is because if I were to do the triangle thing and pick up the special right triangle and place it down right here, that's why it gives me the exact same things, same numbers, same coordinates, because it's just the same triangle I'd be picking up and placing down. But since it's backwards or negative direction for the x, I just have to compensate that I make this negative. Okay, so now let's do all the yellow ones. So all the yellow ones, all the middle ones, these were all the ones that in radians were over 4. And they're all going to have the exact same coordinates as the one in the first quadrant. So square root 2, comma, over 2, comma, square root 2 over 2. So like that. So I'm going to fill all of those in. And in a second, I'll go back and adjust which ones should have negative signs. And it's going to be the exact same ones as before, as what we did in green. So looking over here, this is what's called the second quadrant. Which one's negative? Well, based on the origin being right here, I had to go backwards to get to the x, so the x is going to have a negative sign, but I still went up to get to the y. So this point right here goes backwards on the x, up on the y, so the x is negative, but the y is positive. Okay, and this is just like regular, like in middle school when you plot points, you know that when you go backwards, the x is negative, and when you go up, the y is positive. That's all we're doing here. Okay, so let's do this one right here. So I had to go backwards on the x and down on the y. So both of these are going to be negative, just like both of them were negative when I did this green one right here. Okay, and let's do the last one. I went forwards or to the right with the x, so that's going to stay positive, but I had to go down with the y, so that's going to be a negative on the y coordinate. Okay, so again, I didn't have to really memorize any of those three. They all just came from this original one right here, and then I just flipped it like a mirror image and adjusted for the negative signs. Okay, and let's do the same thing with the red ones now. So these red ones, remember, correlated to the ones that were like pi over 3, 2 pi over 3, all the ones over 3. So I can fill it in with the same coordinates as I did in the first quadrant. So 1/2 comma square root 3 over 2 for all of them. And just go back later and adjust for the negatives. So just like before, this one has to have an x that has a negative sign. This one, they both have to be negative. And this one, just the y has to be negative. Okay? Okay, and then the only ones I really haven't done are these ones right here. And that's because that's just the easy, like 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. That's just going out and up or down by a unit distance of 1. Okay, so you now know the coordinates of all of these angles in both degrees and radians all the way around the unit circle. So I should be able to ask you something now like, what is the sine of 150 degrees? Okay, well, where's 150 degrees on the unit circle? Well, that would be right here, this one that I'm highlighting in green. And since sine is always the y value, then I just steal the y value from it and say sine of 150 equals 1/2, and you're done. So that's how the unit circle is going to be really, really helpful, is you can answer these sine, cosine, all these things really fast once you have these coordinates down. Let me do another quick example. What if I ask you something like, what's the cosine of 4 pi over 3? Well, 4 pi over 3 is right here, and the cosine value would just be the y value, and it looks like that's negative 1/2. So cosine of 4 pi over 3 is negative 1/2, and you didn't have to type anything in on your calculator. So you can see how beneficial it's going to be to memorize the unit circle. And when I say memorize, I mean you really just need to know these first 3 and then know how they all flip to the other quadrants. And last week's video showing you how like this line was 4 pi over 3 and showing you how this line was 150. That's why that's going to be so important now, because now when I ask you something like, where is 315 degrees, you need to be able to tell me pretty quickly that it's right there. Okay, so let's do some examples. What is the sine of 45? So think about your unit circle. Sine of 45, well, where's 45 degrees? In those first 3 sort of spokes, I like to call them, in the unit circle. 45 degrees is this middle one right here. And remember my coordinates for that is square root 2 comma over 2. And sine is always the y value, so the sine is going to be square root 2 over 2, and you're done. So the hardest part of these is just knowing that this line right here was 45 degrees and knowing that sine always means you take the y value. But that's it. That's your answer. Let's do another one. How about the cosine of 60? So again, imagine the unit circle. Think of your those first 3 spokes in the first quadrant. 60 degrees is this one right here. What are the coordinates there? It was 1/2 comma square root 3 over 2. Cosine is the x value, so it's just going to be your x value there, which is 1/2, and you're done. So knowing the unit circle, you'll be able to whip these values out really fast. How about the tangent? Well, tangent is not the x or y coordinate, so we're going to have to talk about how we get that one in a second, but it is pretty quick. But I am asking you to do 150 degrees. So where is that? Well, if you think of the unit circle, 150 degrees, well, 180 degrees would be a flat line. So 150 degrees is just 30 degrees short of that, which means it's just this one right here. And so my coordinates for that are going to be the exact same as they were for this one. Remember, all these green ones have the same. And what were my coordinates there? This was square root 3 over 2 comma 1/2. That was for 30 degrees, or in radians, that would be pi over 6. So then this is going to have the exact same, square root 3 over 2 comma 1/2, except for the x coordinate has to be negative, since I went backwards in the x for this one. So now that I have my coordinates for that spot, how can I figure out tangent? Well, here's a really quick and easy trig identity that you need to know in order to solve things for tangent. So a quick thing for tangent. Tangent is whatever the sine is divided by the cosine. And the reason you get that is because remember that tangent is opposite over adjacent. And with a hypotenuse of 1, So imagine anywhere it says h is just 1, and timesing by 1 doesn't really do anything. So if you're doing opposite over adjacent, what you're really doing is sine over cosine, opposite over adjacent. So tangent is sine over cosine. The way my high school teacher taught us to remember this is we were learning this around spring break in Algebra 2, and she said to get a tan, the sun has to be over Costa Rica, because someone in our class was going to Costa Rica, and I've just never forgotten that. So it always helps me remember that tangent is sine over cosine. So now if I want to find tangent, I already know the sine and cosine values, so I'll just plug them into that short equation that I just taught you. So sine over cosine, well, the sine is the y value, so that was 1/2, over the cosine is the x value, and that was negative root 3 over 2. And that's my answer. That technically is correct, but that looks like a very complicated fraction, so let's make that easier. In fact, you'll never leave an answer like that. So I would want to get rid of this denominator in order to make this look better, and I can do that by multiplying by the reciprocal, and that will cancel everything out in the denominator, but of course what I do to the bottom, I have to do to the top. And, oops, I put the square root on the wrong thing. That was negative 2 over square root 3. Okay, so let's multiply the top. 1 times negative 2 is negative 2, and in the denominator, 2 times square root 3. I can, of course, those 2's will cancel, so that's just negative 1 over root 3. And one last final step is remember you never leave a square root in the denominator. So multiply both top and bottom by square root 3, and you get square root 3 over 3. And actually that's a negative square root 3 over 3 since we had this negative sign right there. Alright, so pause the screen here if you need to look this over. If you're ready to move on, go ahead and continue watching. I'm going to have you guys try a couple on your own, and then I'll check and give you the answers. Okay, so if you're ready for these, pause the screen, try these on your own, and hit play when you're ready to check. So for the first one, the first thing I need to do is know that 135 degrees is right here. That's a middle spoke, so that would correspond to this middle spoke over here, and those coordinates are square root 2 over 2 comma square root 2 over 2. So these are going to have the exact same coordinates, it's just that the x value needs to be negative since I went backwards. Since I'm asking for sine, my answer is just going to be the y value, so that's square root 2 over 2, and you are done. Okay, pause if you need to look at that. I'm going to clear the screen and show you the last one. Tangent of 300 degrees. So where's 300 degrees? Well, I know that, I'm drawing these not very even, I know that 270 degrees is right here, and 300 degrees would just be 30 more than that, so I know that it's this line right here. So that's going to correlate to all of these ones that are closest to the y-axis. And I drew this really quick and sloppy, so excuse the fact that that's definitely not perfect. And remember that these coordinates are 1/2 comma square root 3 over 2. So then these coordinates down here are also going to be 1/2, but then for the y it's going to be negative square root 3 over 2 since I went, see if I can draw that. Okay, there we go. Every time I kept doing it, it was turning the next page. So since I went down for the y coordinate had to be negative. And remember, to get tangent, you're doing sine over cosine. So I'm going to do this one, negative square root 3 over 2 divided by the cosine, which is 1/2. And let's clean this up a bit. So multiply by the reciprocal, which would be 2 over 1. And in the top now, I would get negative square root 3 times 2. And in the bottom, you would get 2. And those would cancel. So your answer is just going to be negative square root 3. And again, the awesome thing about this is if you type this in your calculator, it's not going to give you negative square root 3. It'd give you like a crazy decimal thing. So this is an exact answer, and that's the whole point of the unit circle. Okay, so that's it for today's video. If you guys understand all the coordinates on the unit circle and how to answer questions like I showed you on this screen, then you are all good to go.